Hello, welcome everyone to the AstroBit podcast, brought to you by your home for curated space news, astrobitica.com. I'm your host, Alan, the Astro Writer, and this is our next episode of Astro Wife Asks. In this segment, my lovely wife, Raylene,
hi everybody,
asks me about an astrophysical, astronomical, or space-related subject she's curious about, and I do my best to explain it. It's a fun way to dive into the wonders of the cosmos while keeping things approachable and conversational. So, without further ado, Astro Wife, what are we going to ask about today?
I would like to talk about the best planet today. I want to talk about Jupiter.
Okay, so been hinted at a few times. You have an affinity for Jupiter.
I do. I think it's primarily because of the colors. So, I love to paint. So all the blues and the reds and the browns and the whites. It's just the most beautiful planet to me. So I would like to know a little bit more about Jupiter today, other than why it's so pretty.
Okay, I will indulge you on this one.
Thank you.
I admit, yes, Jupiter does look very nice, right? It is beautiful in a way.
And all the swirling patterns, it's amazing.
Yeah. There are also some other really cool things about Jupiter that make it kind of interesting, and then hopefully we can get to those today. And even we'll even talk about why it does have the colors that it does.
Also, I know Jupiter has a lot of moons, and surprisingly enough, when I was a teenager, I learned about Jupiter's main moons from reading Harry Potter.
Oh, I didn't know that.
Yeah.
Okay. I've read Harry Potter too. I don't remember what that's about.
Yeah, in one of the stories, Hermione is like talking about the moons or something. I don't know. I read these books very long ago, but they talk about Io and Ganymede and a couple of the other ones. But let's first talk about Jupiter's size.
Okay. So yeah, Jupiter is the king of the planets, right? It's the largest planet in the solar system. It is hundreds of times bigger than Earth. It is bigger than Saturn, even if you were to count the mass of Saturn's rings. Jupiter is so large that it is often called a failed star, because if it were a little bit bigger, and by a little bit, I think maybe 10 or 20 times bigger, it would have had the gravitational mass to create nuclear fusion in its core and thus start producing heat and light the way a star does.
Seriously?
Yeah, so Jupiter is so large, it's called a failed star. If it were to absorb maybe some of the other material in the solar system during the early formation, who knows? This might have been a binary star system. Because like most star systems that we have observed are binary star systems, because there's usually enough material at the early stage of a solar system to make two different stars. So Jupiter could have been a star if it had gotten a little bit bigger. Yeah. So other things, cool things about Jupiter's size. So outside of the sun, obviously, the Jupiter is the largest thing in the solar system and the most massive thing, right? Remember, size and mass are a little bit different. Right? Mass is how much you distort space. So Jupiter's the second most massive thing in the solar system, and because of that, it has the second greatest gravitational well, or gravitational influence, on the objects in the solar system. So it collects more things in its gravitational well than other things do. So you hinted at earlier, yeah, it has 4 main moons, Io, Ganymede, Europa, and Callisto. And the moons themselves are pretty unique. They all have different things that make them unique. And then we talked about in the Lagrange point episode how Jupiter's mass is so big it's collected all these asteroids at its Trojan and Greek Lagrange points, right? More than any other planet. But the big thing about Jupiter's gravity is that it is essentially the protector of the inner solar system. So
that's pretty cool.
Yeah, the solar system has all these asteroids and comets from like the Kuiper belt and the Oort cloud and the asteroid belt that are just swooping in and around, the sun all the time. But because Jupiter's gravity is so great, it captures a lot of these asteroids and comets before they enter the inner solar system where all the rocky planets are. Had it not been there to do that, it is likely that the inner planets, Earth especially, would have had far more impacts from asteroids and comets than we had. And who knows, that might have even prevented life from beginning here on Earth if we were just being constantly bombarded by asteroids, or or like what happened to the dinosaurs happened more frequently, where more asteroids came through. So, in many ways, Jupiter is the protector of the inner planets in the solar system.
I also read somewhere that apparently Jupiter has rings. We just can't see them.
Yeah, they're really small. It's much like Uranus. Uranus has rings as well. A lot of the any planet of significant mass is going to collect a lot of material around it, right? Usually through captured dust particles and stuff like that. So it does. They're fairly insignificant. They don't really compare to like Saturn's rings or something like that. But yeah,
But Saturn's rings are icy, right?
yeah, and it's just because of the amount of material that Saturn happened to be around that it couldn't coalesce it into a moon. But yeah, Jupiter has rings, Uranus has rings. I wouldn't be surprised if we found out one day Neptune has a ring as well.
Probably. So Jupiter is also known as the gas giant,
Hmm.
right? What kinds of gases and things are made up of on Jupiter?
Okay, so dispel a common myth first. You maybe have learned in school how the solar system has four gas giants, right? Jupiter, Saturn, Uranus, Neptune. Really, Jupiter and Saturn are gas giants, and Uranus and Neptune are what we call ice giants.
Mm.
But the gases in Jupiter are mostly hydrogen and helium are the big two, right? Because those are the most common elements in the universe. Everywhere, there's just loads of hydrogen and helium. But Jupiter also has a lot of ammonia and methane, which makes it a pretty toxic and unforgiving world. But that is the reason why Jupiter has all its different colors, is because as the ammonia and the methane and the hydrogen and helium, as they're exposed to solar radiation, radiation from the sun hitting it,
Hmm.
it breaks it down at certain levels and causes it to look essentially like different colors at different altitudes and different latitudes on the planet.
And I assume the gases don't mix, hence the swirling colors.
Yeah, exactly. It's different atmospheric pressures at different latitudes on the planet cause it to naturally separate into those bands that you see.
Hmm.
Jupiter has the biggest storm in the solar system. It's Great Red Spot. That's essentially a giant hurricane that is just whirling across the planet. And the Great Red Spot is so large that you could fit the entire planet Earth inside of it. So imagine like a planet-sized hurricane just completely engulfing.
I read recently that the Great Red Spot is getting smaller. Is
Yeah,
that true?
it is. So it is dispersing. I couldn't tell you how long it's going to be. It's probably a couple thousand years, maybe tens of thousands of
Yeah,
years.
not in our lifetime.
Yeah, but it's not one of those things that will persist forever. Like we identified it and we've been tracking it for centuries. And, if humans are around and we're still studying the stars a couple thousand years from now, we may watch it dissipate as well.
Would it ever be possible, because of all the toxicity and the different types of gases and things, it's probably never going to be possible that humans land on Jupiter, right?
No. So Jupiter is a gas giant, right? If you tried to land on Jupiter, you would just fall through, right? So it is gas on
So
its.
there's no land or anything?
Well, okay, so it does have a core. We believe it has a core based on its gravitational influence, right? We think there should be some core at the center of it. However, we can't send a probe in the middle of the planet to study it because the probe would just melt and be destroyed before it ever got to the center. But we believe it has a core that might be solid, but might be kind of molten. This core of Jupiter would be at least 10 times as big as Earth, if not more. So it'd be huge, huge plant, huge like body in there. And we believe because of the immense heat and the immense pressure at the center of Jupiter, that it wouldn't be solid like a solid rocky planet or like a solid core like Earth's core. It would be more of a metal slurry of molten rock and liquid gases, right? And it might be more solid on the outer layers and then completely liquid in the center layers. But yeah, that's what we believe is in the core of Jupiter, some kind of molten metal rock abomination in the middle of this gas giant.
So it's just something we're always going to have to like try and guesstimate because, we can never visit it.
Right,
I
because we can measure so we know how much the gas weighs in a planet, right? Like we know it's mostly hydrogen, helium, ammonia, and methane. We know how much those gases weighs. We can estimate how much of those gases are present from what our observations are, and then we can guess at how much mass that it has. Well, Jupiter's gravitational influence is greater than its measured or its observable mass is, so that leads us to believe that there is a core in the middle, because a lot of planets have cores, and it would
Mm.
make sense that it would have a core. But what its core is made of, the consistency of the core is, that I don't know if that will be beyond our understanding completely forever, or if maybe one day we develop technology that would ensure a probe got to the middle of the planet and could take readings. Who knows?
I always imagined Jupiter as like a rocky planet that just had a bunch of gases and things swirling around it. I never considered that, there was more gas than actual substance
Yeah, the gas
in
is
the middle.
the gas and the dust really is what came first. So,
Mm.
in the early stages of the solar system, and what we call a solar nebula, right? This is when a star is just forming. So all this material, this gas and dust, starts to collect in on itself, and the more it collects, the more it attracts, because its gravity gets more and more influential. So more dust and more metals and rocks start to coalesce into one ball, right?
Mm.
And then as it grows hotter, because more mass is there and gravity is exerting this greater force on it, it starts to heat up, and eventually that stellar material starts to ignite and create nuclear fusion in its core, converting hydrogen into helium and things like that. That's what a star does. So Jupiter and the other planets form from the remnant material in the solar system that didn't get collapsed into the sun at its early phase. So, do you know, because of that, Jupiter hasn't always been at its current location. It was originally much closer to the sun, about where Mars is, and it did what we call planetary migration. It migrated further out, partially due to Saturn's gravitational influence, pulled it further away from the sun, and thus completely disrupting all the stellar material that was there.
Even though Saturn is smaller than Jupiter, it could pull it out.
Yeah, so it helped pull it out, right? It didn't do it by
Uh,
itself, right? But it helped migrate it further away from the sun. And we believe that planetary migration, that move Jupiter had while it was moving out and thus disrupting all the material in the early solar system, is probably why Mars is the size it is. You know, Mars is much smaller than like the other rocky planets like Earth and Venus. Earth and
mm.
Venus are roughly the same size. Mars is like a third the size of Earth. And we think that is because Jupiter collected up a lot of material that would have one day been part of Mars had it not migrated further out.
That's interesting. I didn't know that. Also, back to the moons thing. I heard one of the scientists are quite excited about one of the moons. I think it's Europa, and that it has some kind of potential subsurface ocean or something.
Yeah, Europa's always the one that gets talked about. When we start looking at places outside of Earth, but still in the solar system, where we might be able to find some form of life, Europa is always like the highest one on the list, because Europa has what we believe is a subsurface ocean. So the outer layers are frozen, right? Because it
Mm-hmm.
doesn't have much of an atmosphere to heat it up. So it's kind of exposed to the coldness of space, and that freezes it over. But internally, the core of Europa, as well as the gravitational influence that Jupiter has on it, might be heating up the core to create liquid water underneath the surface. And at least here on Earth, wherever there's liquid water, there's some type of life,
Mm-hmm.
right? Even simple single celled organisms to bacteria and things like that. So that's always what gives us the best chance of finding life outside of Earth, is a place where there's liquid water, and Europa might have a whole ocean of water under its icy surface.
That's pretty cool. I
Yeah.
didn't. Yeah. I mean, I read part of it, but I didn't know it to that extent.
Yeah. Like I said, the moons themselves are pretty interesting. I think Ganymede is like the largest moon in the solar system. It's bigger than the planet Mercury, even. It's huge. I think Io has the most volcanoes. So Io is very volcanically active because its core and its layers are literally being stretched and compressed by Jupiter's gravity. During Io's orbit around Jupiter, it gets closer and further away because it has an elliptical orbit. And when it's closer, the Jupiter's gravity like collapses it and then it stretches it. So it's literally like this planet or this moon is made of Play-Doh and it's flexing in and out. And that causes massive volcanic eruptions and geyser-like eruptions on the surface to spew outward.
Neato.
Yeah.
So last comment or question. Jupiter, because it's the biggest planet, it was also named after the Roman god, like the equivalent of Zeus kind of thing, right?
Yeah. In the early days of astronomy, like the first people to look up at the stars were, early civilizations. The Mesopotamians, the Sumerians, the Greeks. They all looked at the stars and they studied them. And when you look at the shining lights at night long enough, you start to understand that some move more frequently than others. Some are closer. Some have different colors and brighter. So they learned that some of these were not stars so much as they were like other worlds and other planets. And they had really early basic type telescopes that could help them see that these were actual planets and not stars. And because Jupiter was the largest and the biggest, they equated it to the largest and biggest thing that they could, that was in their frame of reference, which were, the gods on Olympus, right? So it got the name for the king of the gods, and they thought that was really him, just up there observing humanity, right? Same thing for Mars. It was Ares, the god of war, and Neptune was god of the sea because it was so large and so deeply blue. They could see the color blue. So, most things in astronomy that are old enough to be studied for the last, hundreds or even couple thousand years, it probably got named after something in mythology at some point.
I wonder why Earth never got a cool name.
Oh, Earth does have cool names. My favorite name for Earth is Terra, right? And then Terra is Latin, meaning land that you were on. So another name for Earth is Terra. And I always like the idea of calling it Terra Prime, like the main planet, because that's where humanity originated from. So we think Terra Prime, I think, is a pretty cool name for Earth.
Be a good name for a sci-fi movie too, or location.
Yeah, definitely.
So, thank you for indulging me in talking about Jupiter today.
Yeah, so I agree. Jupiter's really pretty. I like some of the other planets for other reasons, but there are some really cool things about Jupiter, right? And it's like, if nothing else, it's gravity, and it's the reason why we're probably here today and not being bombarded by asteroids is pretty cool.
That is pretty cool.
All right, thanks so much for tuning into this episode of the AstroBid podcast and our latest episode of Astrowife Asks. I hope you enjoyed our conversation and maybe learned something new along the way. If you want to explore more curated space news, don't forget to check out astrobitica.com and follow us for updates on future episodes. Until next time, keep looking up and stay curious.
Bye.